Hello, welcome to this channel. My name is Enoch. In this channel, we discuss skills and things that are related to cloud and DevOps. And if that resonates with you in any way, feel free to join me. We have been doing a series on Python. We have been using projects to learn Python, and we've completed the beginner level. We have moved to the intermediate level. In this video, we are going to be doing a project on a quiz game using the object-oriented approach. And in this video, we are going to show how to use the zip function. We are going to discuss modularity. We are going to discuss encapsulation, abstraction. There are four major pillars of object-oriented programming. One is inheritance. The second one is polymorphism, encapsulation, and abstraction. In this video today, we are going to be able to demonstrate encapsulation and abstraction. All right, and in this video we have a file here. We have a list of dictionary here, and each dictionary contains a text with key and a question, a string of question, as the value, and we have answer and we have the answer. So the goal of the game is to display this question, display the choices with label, maybe A for red, B for green, C for blue, and so on. And we'll ask the user to give their answer, and if they get it right, we are going to add a score to it. So basically that's what we want to do, and I have drawn a flow chart here that we are going to use. We are going to first create a file, and we're going to call it question.py, and we're going to create a class with first, answer, and choices parameters. This data has key of test, choices, and answer. So that's what we are going to use to create our first class: test, answer, and choices. All right, so we are going to create another file. We are going to call it quiz logic, and we are going to create a quiz logic class with score, question number, and question list as parameters. And we are going to define a method. We define a next question method to get current question, and we are going to add one to question number for every question that is displayed, and we are going to show the available options and label. We are going to get user to guess the answer, and we are going to check if they get the answer correctly by calling the check answer method. All right, so we are going to write a check answer method, and we are going to write a method that will check if there are still any more questions. All right, so we have in this flow chart, we have the question class, and we have a quiz brain or a quiz logic class. And then we'll move to the next flow chart. This is another flow chart. In this flow chart, we will create a file called main.py that is going to be the controller of the game. And we are going to import data and classes. We are going to build a question object from the question class. We will shuffle the question object, and we will create a quiz logic object from the quiz logic class. And we are going to call the next question method while there are still more questions. And once that while loop is over, then we are going to end the game and print the final score. All right, so let's get right to it. So the first thing we need to do, let's go to the first flow chart. We'll create a question.py file, and we'll write a question class with first, answer, and choices parameters. All right, so I've created a question.py file here, and we are going to create the class. We are going to call it question, and we are going to define the init method to initialize the attributes, and we are going to call it test, choices, and answer. And we are going to initialize the attribute like this. And so that's that. We are done with the first part of the flow chart. Let's go to the second part of the flow chart, which is to create a quiz logic.py file, and we'll create a quiz logic class with score, question number, and question list as parameters. So let's go and do that. So I have a quiz logic.py here. I've already created it. So we are going to say class, and we are going to create a quiz logic class, and we are going to define the init method, and we will I will add question list as parameters here. And I will go ahead and do a question score equals 0, and we will also do self dot question number equals to 0, like that. So that's what we are going to use. So no answer here. So we have question list, we have score, we have question number. Those are the parameters, those are the attributes that we need. And let's go and check our flow chart and see the next thing to do. We need to define a next question method to get current question, and we'll add one to the question number. For every question that is displayed, we show available options, we get user answer, and we check if they get the answer correctly. All right, let's go and do that. So I'm going to call this next question, and we are going to create a current question, which is going to be a question list of question number like this. And after this, we are going to add one to cell to question number, and we are going to print we are going to simply print the question. We are going to print the question on the monitor, and I'm going to have q, and we'll have self.question number, and I'm going to just put a dot here, or a colon is okay, and we have self current question dot test. This is what's going to get a test out for us. All right, so this is going to print the test out for us. All right, now the next thing is to display the available choices with label. So I will first say available labels equals to, then we will say, I will open a square bracket, then I will just pick some label. I will just pick A to F like this, and from there we can get active label, and then this will be equal to available label. Then we'll open a square bracket and we'll slice it, and we will get length of current question dot choices. So this will be current question dot choices, right? That's what so this is going to give us the active label. So there are some times that the label just has two the choices are just two, sometimes that the choices are just four. So this is going to make it dynamic. If it's just three choices, it will be able to pick the three choices. If it's four, it's going to be able to pick the four choices. It's going to exclude the last number there. All right, so we have the choices. Now the next thing we need to do is to display the choices on the screen. So we have current question choices, and we have the active label. Now how can we display? So we'll just say for labels, let's make it singular, for label choice, in then let's use zip here, in zip of active label and current choices like this. Then I will say print label and choices like this. Then that will just print it like that for us. So the zip function that you are looking at here is a function that is used to combine multiple iterables, together into pairs, element by element. So it's going to pick, this is a list. If you look, this is a list. Active label is a list. The current question choices too is a list. If you look at this, by the time you use this key, it will give you a list, right? So it's a list, and when the list comes out, it picks one from this. It picks one from this, label choices. Pick this next one, the second one, and the second one from this. That's exactly the way it's going to do it. And once we do that, the next thing we have to do now is to get user input. And before I will let's try and get user input like this. I will say active label of join equals to, then we will join the active label, and I'm going to use user input equals to user input. Then I will use f string, then I will say enter, and I will use colon there, and I will say active label of join like this. So I will just put a space here, and I'll put dot upper here so that it can change this to uppercase because of these uppercase that we have used there. All right, so once they have this, then we will tell them to once they have this, then they will be able to give their input. Then I will want to check if they give the required inputs, and I will say if user input not in active label. Then if it's not in it, then I'll print invalid input. Then I will say we are moving to the next question, right? we are moving to the next question, and we'll return none. We'll return nothing. But if they give the right input, then what is the next thing we need to do? Let's get the user choice. Let's get the user choice. So I'm going to try and get the index of this user input. So I'm going to use index equal to active label dot index. Then I will use it like this, and we are going to use index to get the user choice. User choice, which user choice will be equal to current question choices of index like this. So this is going to give us the user choice. If the user choice is A, then in this kind of choice, in this place, then it will be red. If it's B, then it will be green. That's just what we are trying to get out of this. All right. So once we get this, then the next thing will be, all right, now the next thing is to check if they get the answer correct, right? So I will write a method to check answer. I will write a method to check answer, and I will add user answer to it, and I will also add correct answer to it. All right, so user answer and correct answer. All right, but before we go, let us call the function here. So I'm going to say self dot check answer, and we are going to give it user choice and the current question of answer like that. So user choice, current question of answer, that's what it's going to take. All right, so let's complete this method. In this method, we will check if the user answer is equal to correct answer, and I would like to change this to lower, and I will change this one to lower 2 like that. And if this is true, then we will increase the score by 1, and we will simply print correct, and I will simply use f-string and say correct, and I will say the answer was, then it will be correct answer, not user answer, correct answer like that. All right, correct answer. So and if that is not the case, then we will print incorrect. The answer was correct answer like that. So, and once we do that, then we print their current score. Then I will use f-string, and I will say your current score. Your current score is self.score with self.question number like that. So if they get 2 out of 3 questions, that's what will be printed out. It will be 2/3, right? That's question number. So that's what we are going to do. All right, now let's check the next thing to do. The next thing to do now is to write a method to check if there are still any more questions. And let's go and do that right here. And I will define it. I'll call it check. I will say still as a question, and we'll call it like that, and we will simply return self.question with length of question like this. So what this is going to do, this is going to, every time we call the next question method, it will increase, it is increasing the question number by 1. So by the time we call the last question, it will add 1 to the question number, and it will be equal to the length of the question list, right? So by that time, this return, it will return false, and we'll be able to use it to break out of the while loop function in the other flowchart. All right, so that's that for this particular one. Let's go to the next flowchart where we have the main brain of the game. So we'll create a main.py file. We import data and classes. Let's go and do that. So I've created a main.py file. Then we import all the classes and the data. So from this data, we import question data. From this quiz logic, we import the quiz logic class. From this question, we import the question class. So I will say from question import question. Then I will say from quiz logic import quiz logic, right? Then I will say from data import question data, right? and we will also import range. We import random. We import random. All right. Now, the next thing we need to do now is to create a question bank object from the question list. So we are going to use list comprehension to do that. I'm going to say question bank equals to, then I will open a square bracket, then I will say question, then our question class has three attributes: test, choices, and answer. So we are going to use positional parameter placement to define our list comprehension. So I'm going to open parentheses here like this. I'm going to open parentheses, and I'm going to say quest of test like that. Is dictionary. So we are going to call the key like that. Then I'm going to say quest of choices, and we'll get out of that. Then we'll say quest of answer, and we'll get out of that, and we'll say for quest in question data like that. All right, so this is the question data, and it's going to use this to create a list over here. All right, so it's going to loop through this data. And it's going to use it to create a list for us over here of question objects, right? Using this question class, right? So that's that. Let's go and check what's the next thing on our flowchart. The next thing on our flowchart is to shuffle the question bank. So I will go there and just say random of shuffle of question bank like that. So once you shuffle it, what's the next thing we need to do? The next thing we need to do is to create quiz brain or quiz logic objects using the question bank list. All right, we have a quiz logic class here. So I'm going to go and use that to create an object. We'll create an object from this class, and we will use this accept a question list parameter, and that's what we are going to use this question bank list for. All right, so I'm going to just say quiz equals to quiz logic of question bank. We are creating an object from this quiz logic class. That's exactly what we are doing. All right, so once we create this, then what's the next thing we need to do? The next thing we need to do is to use a while loop to call the next question method. All right, let's go and do that. Then I will say while quiz of still as a question, and I will use it like this, and I will simply say quiz.next question like that. So we will run through this. We use this method. In as much this method return true, then this statement will be true, and it will call this next question, right? If you look at this logic here that we use here, in this still as question, we return self.question number less than length of self.question list. So and this question number start from 0. If this in this next question it start from 0, then every time the next question is called, it will add 1 to it. So by the time the last one is called, it will be equal to the length of the question list, and this statement will return false, and to break us out of the while loop. So once we're out of the while loop, what's the next thing we need to do? We simply need to finish the game and print the score. All right, so I will simply just say print the game is over, right? The game is over, and let's print their final score. I will say your final score was quiz.score. Don't forget that this is an object that we are using to call this attribute. We created this object from this class. This attribute belongs to this class. All right, so you say quiz.score, and we will also get the question number, right? So if you answer 2 questions out of 3 questions or 4 questions, you just say 2/4. If you answer 1 question out of 9 questions, you just say 1/9. Whatever you are able to answer, that's the way it's going to display it. So you may want to label it end game and print score, and we'll say you can call this one you can call this checking if there are still more questions and you can call this one quiz logic objects, right? You can call this one question objects. So that's that. So we have our main brain of the game here. We have our data here. We have our quiz logic here. Then we have our question class here. Let's run the program and let's see what we have if everything goes well. All right. If you die in the House of Parliament in London, you are entitled to a state funeral. That's not true. That's false. So, all right. I need a space here. So let me put a space here. So in this check something, I'm going to just put I'm going to put a new line there. All right. So that's okay. So let's run it again and see what will happen. Which animal? You can see that it's displaying different questions when starting the game again. Which animal produced the loudest sound? That's blue whale. B. And the answer was blue whale, right? Your current score is 1/1. Yeah, that's exactly what I want. You can lead a cow downstairs, but not upstairs. That's false. You can lead them both ways. You know, the answer was false. Your current score is 2/2. This is working as I want it. In West Virginia, USA, what happened if you hit an animal with your car? You must report it to the police. You are free to take it home to heat. You are fined. You must bury it on the roadside. No, you are free to take it home to heat. You're free to take it home to eat. So the answer was all right. So approximately what fraction of human bones are in the feet? 1/4, 1/2, 1/3, 1/10. I would just say 1/4. That's correct. The answer was 1/4. Then, so for a few ounces of chocolate can kill what kind of animal? Let's say be a cat. Incorrect. The answer was a small dog. 4/5. It is illegal to pee in ocean in Portugal. It should be legal anywhere. So I'll just pick A. Incorrect. So the total surface area of human lungs is roughly the size of basketball court. Of course not. Tennis court, swimming pool, football pitch. Okay, I'll just put big football pitch. 6/7. All right. So if you die in the House of Parliament in order, you're entitled to state funeral. True or false? You should be entitled to a state funeral. Incorrect. The answer was false. Your current score is 6/8. Buzz Aldrin's mother's maiden name was what? I'll pick Moon. The answer was Moon. All right. So what was Google's original name? Backrub. That's correct. So it's logged. So we can just rush through it like that. And your final score, you say the game is over. Your final score is 8/12, right? That's exactly what we want. All right. So now we have been able to display something in this project, and the first one is modularity. Modularity is a situation where you break a big program into small organized files. We split this project into multiple files. We have a question class in a question file. We have the quiz, the logic of the game in another file. We have the data in another file. We have the controller of the main controller of the game in another file. Right, and if you look at it, each of them can be worked on by different developer. So each of them can scale as they like. You can add to the database, you can add to the quiz logic, you can add to the question. Each of them can scale, and this is modularity at play for you. It makes your code easy to read, easy to debug, easy to update or replace parts. And it encourages teamwork. And one of the pillars of object-oriented programming that we'll see at display is abstraction. Abstraction is showing only what is necessary and hiding the details. If you look at this brain, I only call the next question here, and this next question, is what does the rest of the magic. It get the next question. It's added to the question number. It's added to it's called the check answer method. So we are only showing what is necessary here. We are hiding the complexity in this quiz logic. That's abstraction at play for you. You interact with an object using, a simple method name without needing to know how they work internally. That's exactly abstraction at work. And the last pillar that we show here is encapsulation. Encapsulation simply means that you keep related data and functions together, just like we did in this question class, which we used to create an object over here, and we also went to the quiz logic. We created a quiz logic class with the required attribute and method. That's encapsulation at work. All the quiz data, the score, the current question, the question list, they are stored together in the logic, and only quiz logic method control how these data can change. That's encapsulation at work for you, and this will avoid accidental data modification. It will keep your data safe, makes your program more stable. It will make it easy to change internal logic without breaking other code. So that's that for today. In conclusion, the quiz game demonstrates three important principle: modularity, which is splitting the program into separate files, each with a single responsibility; where abstraction, which is hiding internal complexity and exposing simple methods, like that next question that we used there; and encapsulation, which is storing and protecting the quiz data and behavior inside a quiz brain class like that. So these principles are very, very important. Pay attention to them, research about them, and that's that for today. Thank you for watching, and I will see you in the next video.